Welcome, guys. Today we have a colleague who is going to show you or to take you through physics. As you may know that on this channel, mostly we present mathematics lessons. Now today we have a guest teacher who is going to solve a physics paper that is pure. So we are going to go through the questions so we can begin.
So the question we are solving is from the question paper. As you can see, we are solving question 1 from section A, which is about 50 marks. But the question we want to attempt is 4 marks. So the instructions say you have been told to answer all the questions in the spaces provided on the question paper. So you need to follow instructions as you do the calculations. And so we are solving question 1, which is saying figure 1.1 shows an engineer's calipers used to measure the diameter of a ball bearing. So a ball bearing, you need to know that is something that is spherical, meaning that it takes the shape of a sphere. So we need to know that some of the calculations will require us to have the basics on how to solve some questions that involve a sphere. We need to know how to calculate the area of a sphere and the volume of a sphere. We need to know how to find the diameter of a sphere and how to find the radius of a sphere. Without wasting much of our time, we need now to look at the engineer calipers given in the question. The engineer calipers, as we know, they are able to measure the diameter of the sphere of a ball, as long as it's something that is spherical, or maybe the diameter of a pipe. As we know that the measurement can be done. If I are using an engineer calipers, then you need to take the measurement from the object, and then you take it on the ruler to measure, to know the exact measurement that is given. So like this question, the measurement, they have already measured it for you, then they have taken it on the ruler there. So we need now to take the measurement from the ruler. Now remember that where the engineer caliper has been put, it's not starting from 0, it's starting from 1 centimeter to 2 centimeters. So to know the measurement that is there, we need now to subtract the 2 values that are given. So you have the final reading. You have the final reading, which is so you have the final reading. So we say the diameter will be so we take the final reading. We'll take the first reading, which is given as 1 centimeter. It's starting from 1 centimeter. And then the second reading, which is 2 centimeters. So we come to calculate by saying the diameter of this will be equal to the final reading minus the first reading. Now, if you are to substitute these values, you find diameter equal to 2 centimeters minus 1 centimeter, which gives you diameter equal to 1 centimeter as your final answer. take note that as you do the calculations, if that engineer's caliper was put at 0 first, you wouldn't have subtracted the 2. You would have gone to the last reading or last value, the jaw of the engineer caliper, the last one. So when you come to calculating question B, you have to understand that on this one, you need the mathematics. The topic that you looked at, of course, is mensuration, where you looked at how to find the volume of a sphere. Remember in the preamble, we did mention that the ball bearing that is given is taking the shape of a sphere. So we need to remember that the formula for calculating the volume of a sphere will still apply here, which is V equal to 4/3, then pi r to the power 3. As you know that volume is simply the space in 3 dimensions. So we need to take the dimension that is given here is simply the radius. So we need to take the radius, we multiply the radius 3 times. And that is going to give us the units that are required for calculation of the sphere. So we know that the radius in this case, radius is simply r equal to diameter over 2, because we know the radius gives you, if I were to add the radius twice, you get the diameter. So that's why we are writing the formula as d/2. So we are going to say radius equal to diameter we have found is 1. So write 1 centimeter divided by 2, which will give us r equal to 0.5 centimeters. So what you have found there is just the radius. So we get that value, we substitute in this formula that we have written. So when we have to substitute, we find V equal to 4/3. Then the pi, you can take it as 22/7, or you can take it as 3.142 multiplied by 0.5 to the power 3. Now, as you do the calculations, for those who have problems with solving fractions, you need to make this one a fraction and also this one a fraction. Multiply the numerator separately, and also you multiply the denominator separately. The answers you get, you divide them. But take note that this other side here is a complex part. So you need to simplify this one first. Simplify this one so that you can have a 1 value there that is going to multiply by the other numerators. And then later on, you come to multiply 3 by 1 and by this one, so that you divide later. Now, if you are to multiply the numerators, you are going to find the answer as 1.571. Then when you are to divide by 3, you get your answer as 0.552 centimeter. Now take note of the SI unit that you are supposed to use. You are supposed to use the centimeters, since what you are given are centimeters. So you are going to find the centimeters because the first answer was found in centimeters. So this answer you have found here is rounded off to 2 decimal places. But on the calculator, you are going to find that you have about 10 digits. We have just rounded off to 2 decimal places. So we move on to the last question on this first question, which is saying, calculate the mass of the ball bearing if its density is 8.05 grams per cubic centimeters. Now take note that the units that are given for density, they are in grams per cubic centimeters. if the units were in kilograms per cubic meters, it was very important that you convert the volume you have found on top there to meters, to cubic meters. Now, you can also do it by converting the radius you have found initially there to meters, so that when you come to the volume, you don't convert it again. But since we are given the density in grams per cubic centimeters, and then we have also found the volume in a cubic centimeters, then these two are compatible. They can work out. So we can say mass of an object is given by the product of density and volume. So we read this one as rho. Rho is for density and the V is for volume. So we get the density that is given, we substitute under the volume we have found there, we substitute to know the mass. So we say mass is equal to, the density given is 8.05 grams per cubic centimeters multiplied by volume to 0.52 cubic centimeters. Now take note that the units are going to divide to give us the final unit that is needed for mass. So if you check, this cubic centimeters will divide there, and this one will also be divided like that. So what we are going to find now, it will be in grams. So when we are to multiply 8.05 grams by 0.52, we are going to get our answer as 4.19 grams. If you want, you can leave also your answers in kilograms, but take note that the units that are given here, you have been guided. So the units are supposed to be in grams. Just because the density is in grams per cubic centimeters, and also the volume is in cubic centimeters. So your final answer will be 4.19 grams. Now take note that this answer is in 2 decimal places because the first answer was in 2 decimal places. So these are the answers for the first question. So take note of these formulas here as you come to calculate, as you come to solve these questions. So I think I need to put these in, I need to put these I need to enclose them to make an emphasis that these are the formulas that we have used here in our calculations. So whenever you're calculating here, always remember to use these. If it's on something that is spherical, it's talking about volume, you use this formula. If it's something that has to do with the area, use a different formula, of course, which is not part of our discussion. So I think this is where we end for today's lesson.